Hello, it's noontime. We'll get started. This is Dr. Chow, Dr. Eric Chow. We'll get started. Today we will be on the lecture 11, week 11, the scanner design. This actually is one of the two chapters on the tokenization. The second part, last week we are on the Yacc tokenization. Basically, you actually use a finance state machine and hardcode your tokenization stage. So this week we are on the scanner design, and basically this one would be using the table-driven or systematical way of doing it, that actually using the so-called compiler. Okay, how to generate a compiler? Okay, the automation of the generation of the compiler or the scanner part. So that's the topic. So we are going to talk about what is compiler. Compiler is actually a compiler designed to generate a compiler. Okay. This portion I have to talk about it. When you learn the C++, level 1 basic C++, level 2 C++, object-oriented programming, and then you go level 3 C++, data structure and algorithm. And then level 4, you are on C++. This is the structure and interpretation of computer program. Is the course that we are taking on, the programming language and compiler structure. And then the next one, you will go design a compiler. And then you want to generate a compiler that can create a compiler. So this one take in the regular expression and context-free grammar, and it will generate a compiler itself. So nowadays, you also have the AI. So AI is on top of this. You kind of using the natural language, and then you create a large language model. So you can translate from the high-level language to code generation. Okay, so that is yet another level of the compilation now. But nowadays, this course, we are up to the compiler, but this kind of large language model is the AI topic. But you see, the computer science keep progressing from very low level up to the very high level now. So first, we will talk about what is compiler. We will talk about Yacc and Yacc, Flex and Python, okay, and Pre. This one's Python, Yacc and Yacc, okay, Python version of Yacc and Yacc. That's the version we are going to show right here. And okay, and we'll talk about how to write a regular expression, and then how to enter your regular expression to create your tokenization stage. Okay, and we use a simple pre-scanner design. Okay, so this is a whole topic on compiler, especially for the tokenization stage. So first, we go into the overview for the Yacc and Yacc. So Yacc is a lexical analyzer. It's actually published by the Yacc and Johnson on a paper on Yacc and Yacc. This is compiler, very old topic. And then they are brought into the Windows environment. It's called Flex and Python. Okay. So for Flex and Python, that's a Windows version. If you are interested in this Flex and Python, we do have a video series. The first year that I teach this course, programming language, we do have the recorded session right here, and it covers the whole regular expression, context grammar, scanner in Flex and Yacc, and parsing Flex and Python. Okay, and then that actually is very good. So I suggest you to read, actually watch this one. V1 session 2, V2 session 1. week 2, session 2. These are on the flex and legs, the older version of the video that we have. Hello, how are you? Okay, so that's the Windows version of the flex and Bison. Okay, and the purpose of this software actually is that you get a expression and you would like to generate using the lexical analyzer. So you would use the lex and then using the patterns to generate the lexical analyzer. This we call it regular expression, or sometimes we call it extended focus norm form. Okay, actually is this two actually is similar. You can write regular expression or you can write extended focus norm form. Either one of them, you can use them to generate a lexical analyzer. And then you can actually write a context-free grammar and then using the Yacc to generate the syntax analyzer, and you will generate the syntax tree and do code generation. So this one is the structure of your compiler, and you will translate a expression down to the machine code. Okay, down to the machine code. So that's lexical analyzer, and we call it Flex. That's the Windows version. And it actually write the regular expression in .l file. .l file is the extension .l file. That's called lex file. Okay, and then if you have a .y file, that's actually the content-free grammar. That's for the syntax analysis. That's the later stage. That's for Python. Okay. And then you get started, you actually use the Python and then created a calculator.tab.h file and included by your lexical analyzer. And with the calculator.l language, you will generate a lexical analyzer that in C language. Okay. And then this combined with the result from Python, these two you combine, you will create a compiler. That compiler is called calculator compiler. And then this calculator compiler, you can have a calculator language program feed into the calculator compiler. You can generate an executable file or using it as an interpreter. Okay, and you can get results. So this one is how to use a Flex and Python to work together. So if you are interested in these two software, you can watch the video playlist that I talk about in the 2017 course series. Okay, so right here, actually teach you how to create the in the Windows environment, how to create the y.tab.h, y.tab.c files, and then how to create your lex.yy.c file. Okay, and then how to create compile. So this one is to create a compiler. Okay, that's the building process for it. Anyway, these are for C, C++ environment, and you can look at that video. But right here, we will actually look into another thing that's called lex theory. And lex theory is here we have the later, or digit. Okay, so this one is the description for a ID available V123 X, Y available. Okay, something that this is the so-called regular expression code. So star means 0 or more. This one means or, the option or. This one is grouping symbol. Okay, so basically this whole thing means that you have a later followed by a later or a digit. Okay, and this one go this way. These two go this way, and this can recursively. Okay, so that's your syntax diagram for it. So this one is the syntax diagram being translated to a final state machine. Okay. So this final state machine, from final state machine, you can design a Yacc lexical analyzer using the final state machine. So this one, in the previous lecture, we already talked about how to do coding for it. And at the same time, this one, you can use it to create a compiler to program to create a compiler for it. So before you do that, you need to learn this regular expression language. And that means that any character, \n means the change line, star means a 0 or more copy, plus means 1 or more copy, question mark means 0 or 1 copy, cat means beginning of the line, $sign means the ending of the line, A/B, A vertical bar, B means the or B, A, B plus means 1 or more AB, 1 or more AB pattern. A plus B, double quote, that's the literal A plus B, double quote. And then this one is a set, character set, so it actually is ABC, one of these is called bracket ABC. So your ABC will create ABC later. ABC star, it will be AB, and then that's 0C, or ABC, that's 1C, 0C, ABCC, that's 2C, okay, or more. ABC plus is actually AB, but at least one or more C. One or more C, you have 1C, 2C, 3C, okay, whatever. And ABC plus, that's A and one or more copy of BC. So you will have A, BC, or A, BC, BC, or A, BC, 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 okay. A, BC question mark, that means that you have A and then 0 or 1 copy of the BC. So you got A, ABC. This bracket ABC means that one of the ABC, only one of them. Okay, bracket A dash G means that from A to G, any lowercase letters. A backslash dash G, that means you have A followed by G, A and dash and G, 3 letters, one of them. Bracket minus AG means that you have one of the dash A and G. Bracket A minus G, AG, A minus G, 0 dash 9. This one means that one of the letter or digit, and you have one or more copy of it. Space, backslash T, backslash N, these are white space letter, one or more copies of them. Space cap AB means that your word starting is a word accepting any of the letter accepting any of the character accepting A or B. A cap B means that A followed by cap and B. A or B means A bar, vertical bar and B. A vertical bar B means A or B. Okay, these are the so-called grammar for a regular expression that is used for the flex language. So you write your expression there, and then here are the different functions that your Lex file will generate, including the YYLex, that's the lexical analyzer program, and a current character pointer called YYText. Is you have a file, and it's pointing to which character, that's called YYText. And YYLen means that the length of the match string. YYL value means that the token that associate with the value. YYWrap returning 0 or 1 means that you have wrap or not. And then you have the input file and output file called YYIn and YYOut. That's a file name. Okay, and then you have beginning section, initial section, beginning section, and echoes. So these are grammar for the next language, and then your program will look like some definitions, percentage used to divide the sections. There are 3 section: definition, rule, and user programs. So right here, this is a simplest program. You have no definition, \n and that, and no C program. So this one is flex.0.l, the first program. This one just do nothing. You create whatever file by itself. The second one is this one. You do have no definition. Every later you just echo it, you just print it out. Change line, you echo it. So this one also do nothing. And then your main program, you have YY return 1, and you have YY lex. Your program will just run the YY lex and do nothing else. So that's the demo program number 1. Okay, so right here, your main program do this. And this one set up your input file from YY in and output file from YY out. So let's see, you actually use it and then create a tokenizer, and your program is right here. This program will be fed into your lexical analyzer. Okay. So this is a test program feed into the target lexical and then analyzer. Okay, right here is another version. This one called flex2.l. No definition is actually say optional, no YY-ref. So this one, writing this one, you don't need to define the YY-ref function anymore. And then in the definition part, you create a variable starting from here to here. That variable called YY9 number. 9 number means that you keep track of the line number. So when you see a change line, then your YY9 number will increase. And at the same time, you will print out current string in the buffer that the whole line will be copied. So this one is your flex.2.l program, and it will generate a function that's called yylex.c. And the yylex.c you can include it in your main program, and it will be used to perform the print out the line number and each line. And the next one is flex3.l. Okay, this one is actually counting the number of the character. Whenever you have a character defined over here, it will increase the counter. So it will be used to calculate how many token identifier you have. Okay, then you can count the number of line, number of character. This one is flex4. Okay, if you have still interested in any of these, again, please watch the video series that we have that I show you right here. This one is the recorded session for this same course in spring 2017. We do have description for the Flex and Python right here. Okay, and Flex and Python are downloadable from the internet if you have a Windows PC. Okay, you can do that. But for this chapter, we actually do not require you to work on this Flex and Let's just give you the idea of what they are. Okay. And next one is the Pegasus form. Okay, so you will be passing on the token for Pegasus form, and then you talk about what is the Pegasus form, extended Pegasus form, and here has a whole description for it. Okay. Okay, whatever. So you can study the regular expression. Right here, we don't go into there. It's too much. Okay, too much for the class. So here we do give you the introduction for everything related to it. Okay. And we do have a video that you can actually watch it. Okay, so right here, we just bypass them. Okay, so that one is to write the regular your syntax file, your regular expression in the so-called extended Baker's norm. Okay, here more that you check the patterns. Okay, anyway, let's move a little bit faster. So these are detail of this kind of the different regular expression. Okay, you just study it. Okay, this part I give you the example. Move on. So by themselves, it actually is a big topic. Okay? And then we come to here. Next one is actually we talk about a finite state machine. Okay, anyway, we talk about the Python and Flex. Now, that is not what we would actually introduce here. Okay, that actually you can study the C double plus version for it. But right here, we are going to introduce another version that's called okay, PLY, Python version of the Lex and Yacc. So this one is a Python version, and Python version is quite different from the C double plus version. So you go to the internet is Python Lex and Yacc. Okay, so here you have a whole tutorial of the Python Lex and Yacc by David Beardsley. This one, I believe he is a professor at University of Chicago, and he tried to write a Python module for Lex and Yacc. So this one become a Python module. So whenever you would like to write a lexical analyzer, you just import it, then that's good enough. So it's easier to use compared to the C double plus version. C double plus version, you need to write the extra program to generate the lexical analyzer in C language, and then you include it in your program to compile it. Right here, you don't need to include it and generate the file separately. You can use the Python Lex and Yacc program on the fly. And here you have the whole tutorial right here. Okay, so I don't go into this whole tutorial, it's too much. You can study. Okay, it's actually a long story. Anyway, go back to our material. So that's actually this one called Python Lex and Yacc. Okay, and we encourage you to play around this version. Okay, play around this version. So this version, because it's a Python program and it's actually a module, so you need to install it first and then import it to your program. Okay, import it to your program. So basically, the website will show you already. And you were using the LR parsing rules to generate a Lex and Yacc for you. So basically, including lex.py, the token generator, and the yy.py, two module of a grammar parser. Okay, so you want to install it, you need to go to Python installer.org, okay, for this version. And then you come to here, and my version is pre 3.11. That's all time ago. Right now, whether they have a new version or not, I don't know. But you keep install pre, okay. And then you install it, you should get something here, okay, whatever. And then here is a calculator language. So you actually write the whole thing in the Python format, okay, whatever. So this is your beginning of your program, you write the pre.lex as lex. Okay, this one is import the module. The lex is the lexical analyzer portion. And then you define your tokens with this different kind of codes and number plus minus time, whatever. Okay, and then you have a T rule. T rule is 3 underline plus, that is your regular expression. R means regular expression, format of symbol plus. Backslash plus is a symbol plus, symbol minus, a symbol star, slash, symbol parenthesis. Okay, these are the regular rule for these different symbols. And then there is a function that would be a regular expression generator action code for the numbers, for the new line mark, okay, whatever, these are different ones. And then you create a lexical analyzer. This one actually you import it from your modules, imported modules. And then this one, you will actually run these different functions. So basically, this one is not compiling together with your lesson flags. Instead, it's calling the function that defined by yourself and the symbol tables that you build by yourself. Okay, when you testing it, you put the whole program into a string. You can put them into a file and then read it as a whole string, and then this one being feed into the lexical analyzer. So this program, every time you got a token, and if not a token, you will jump out. Otherwise, you will print the token and then read a new token and keep reading the different tokens until you have no longer token and you will get out. So this is the program structure to interpret, to actually tokenize your string. Okay, your string input is right here, and your next that input will actually tokenize them. So after the tokenization, you say there's a number tokenization plus that is here number and then plus and then 4 and then times number plus number times. This one is the number. This one is the number value that you get. This one is the starting symbol, the line 2, character 1, line 2, character 3, line 2, character 5. Okay, it's a line and character locations. Okay, so that finished the tokenization. Okay, that finished the whole tokenization, and then it is performing like so here we actually also build a parser for the same language. So you do import print that lex as lex. Okay, and then you have the lexicalizer. And then right here, not only interpret it by tokenization, but you also would evaluate it. So you also have the expression evaluations. Okay, and then you import your YYLex, print that YLex, Yacc, and then your parser is Yacc modules Yacc function. So you input a line, and then you will pass it. Input a line, you will pass it input. So this one is an interpreter design. Okay, you compile it, you get a result. Okay, and that program can be run. Okay, you can download and run the program. Okay, so today our main purpose is to go through the use of the Python legend Yacc function, and it is used to automatically generate the lexical analyzer for you. And in the middle, you need to learn how to write the regular expression. And that one, you can go through our video to learn how to do it. It actually has a lot of regular expression definition and how to write the regular expression part. And that part, I don't repeat again right here, okay? Any questions so far? Any questions so far? Hello? Any other question? Hello? Any other question?
I think it's okay.
It's okay.
Yes.
Okay, if no question, that's it for today, okay? Today is actually going over to the Yacc and Yacc theory, and then we do show you how to use them in Python environment, okay? And the only thing that you need to know is you must practice the regular expression part, knowing how to use them in Python, okay? And with the help of the regular expression and the pre, you should be able to write your own calculator tokenization and try it. Okay, try this different one. We do have the calculator.py that you can use it for the lexical analysis and parsing. Okay, no question. That's it for today. Okay, thank you. Bye bye.